Right, so we now deal with the November 2020 exam, the N4 exam. So this was the first question. We were given f of x is equal to x cubed minus x squared minus 2x. You can always double check everything. I've sent it to you on your WhatsApp group, x cubed minus x squared minus 2x. So the question is, and I just wrote a summary of basically what they want here. This is the full question. Calculate by using differentiation the coordinates of the turning point and the point of inflection of the cubic function. Also distinguish between the maximum and minimum turning points by using the second derivative, 9 marks. Okay, so now let's see what we're going to do. So we have f of x is equal to x cubed minus x squared minus 2x. Alright, so you know that f prime x, which is the first derivative, is what you need to find. Okay, you need to find that first derivative. So what is f prime x? F prime x here is 3x squared minus 2x minus 2. So now after you find your first derivative, we can now find our turning points. So at the turning points, f prime x, the first derivative, is equal to 0. So what do? We take this equation and we make it equal to 0. So 3x squared minus 2x minus 2 equals to 0. We try and factorize, or if we cannot factorize, we can use the quadratic formula or completing the square. Can this be factorized? Cannot be factorized, so we use the quadratic formula. How do you check if something can be factorized? All you do is you work out b squared minus 4ac. So that is minus 2 squared minus 4 times 3 times minus 2. You work this out. Minus 2 squared is 4. Negative and negative is positive. 4 times 3 is 12 times 2 is 24. So 24 plus 4 is equal to 28. And the number 28 is not a perfect square. If the result of b squared minus 4ac is not a perfect square, that means the quadratic that you have cannot be factorized into prime factors. So therefore, it's up to you. Complete the square or use the quadratic formula. Quadratic formula will get you to the solution quickly. So let's use the quadratic. That's why it's 9 marks here, I can see. Because it cannot be factorized. You need to use the quadratic formula besides the other stuff. So the quadratic formula. So remember, if I had an answer of maybe 25, 25 is a perfect square because 5 times, or basic 5 times 5 is 25. The square root of 25 is 5. So then you'll know that this can be factorized only if b squared minus 4ac is a perfect square. So the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, which is this part here that I just checked now, the part inside here. Okay, this is the part that determines the nature of the roots. So now all over 2a. Alright, so let's do our substitution. So that's minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what is your a, b, and c here? Your a is 3, you can see that. B is minus 2 and c is minus 2 also. So we got minus b, which is minus 2, and then you got minus 2 again, you got 3, and you got minus 2 all over 2a, which is 3. Right, so that is the quadratic formula. So x is equal to 2 plus or minus, because a negative times a negative is a positive, the square root of 28, we already worked this out here. 28 all divided by 6 there. So what does this mean? It means x is equal to 2 plus the square root of 28 over 6, or x is equal to 2 minus the square root of 28 over 6. Let me the calculator there. Two plus the square root of 28 divided by 6, which rounded up to 3 decimal places, that is 1,215. Now just use the arrows and change that positive to a negative, and we get minus 0,549. You all got that? Alright, so now we found the x values of the turning point. For every x value, we need to find the corresponding y value. Okay, so now you will substitute the x values into the original equation. So you're going to go f of 1,215 into the original there. So that's 1,215 to the power 3, 1,215 squared, and then 1,215, and you'll get an answer there. Then you will do the same for minus 0,549. Alright, so let's see what we get. First one is 1,215. Let me use a faster calculator. Let me that. Okay, let me this one here. Alright, so first one, 1,215. So we get minus 2,113. You got that? Then we substitute minus 0,549, so that's minus 0,549, and we get 0,631. Right. So those are our two turning points. So we have a maximum and a minimum. Now this cubic graph only has two turning points, so by inspection we can tell which is the higher turning point, although we have to prove it using the second derivative, but we already know which is the answer before we even prove it. Okay, now we compare the y values. The higher the y value, that will represent the maximum turning point. Right, so we got a negative and a positive. Obviously the positive is higher than the negative, so therefore this is the one which is the maximum, 0,631 and minus 0,549. So the minimum is 1,215 and minus 2,113. Right, so that is by observation, just by looking at which is higher and which is lower. So now that was maximum and minimum. So what else do we need to find? POI, that's point of inflection. Okay, so now to find the point of inflection, we find the second derivative and we make it equal to 0. So in order to find the second derivative, I need to know what was the first derivative. So let's write this down. So what was the first derivative? My first derivative is equal to 3x squared minus 2x minus 2. That was the first derivative. So now the second derivative. you differentiate this one more time. The derivative of 3x squared will be 6x, derivative of minus 2x is minus 2, and the derivative of a number, a constant, is 0. Okay, now at the point of inflection, second derivative must equal to 0. So at the point of inflection, the theory, you memorize this here. Your second derivative must equal to 0. So you take that second derivative, there's your second derivative here, which is 6x minus 2, and you make it equal to 0. And now you're going to solve for x. So here, 6x is equal to 2, so x is equal to 2 over 6, which is the same as 1 over 3. So now, we need to substitute, we need to find the corresponding y value for this x value of 1 over 3. So, to find a corresponding y value, you will always substitute the x value into the original equation, which is this one. Alright, so we're going to go f of 1 over 3 is equal to 1 over 3 to the power 3 minus 1 over 3 squared minus 2 times 1 over 3 and we get minus 20 over 27. Which is minus 0,741. That's what I get. Anyone got that? Okay, I've got it. So therefore, your point of inflection is 1 over 3 and minus 0,741. So so we got the maximum, we got the minimum, we got the point of inflection. But one more thing, yeah, this is 9 marks. They want you to show how to prove which is the maximum and minimum by using the second derivative. So how do you do that? Let me just show you. All you have to do is write down what is the second derivative. Okay. So what you're going to do is you will substitute the x value of your turning point into the second derivative. So there's a second derivative here. Second derivative is equal to 6x minus 2. Right. Then you will take your turning point. Let's take this turning point here. So you're going to do a test. You're going to test out this turning point. So which is minus 0,549, 0,631. So what you will do is you will substitute the x value, because there's only a place for x here, there's no place for y. You substitute the x value of the turning point into the second derivative, and if your answer is negative, that means you have a maximum turning point. If it's positive, it will be a minimum. You memorize that. Okay, that's a theory required here. So I'm going to go f second derivative of minus 0,549. So we will substitute into the second derivative, and we'll get an answer. Then you do the second one too, which is 1,215 minus 2,113. substitute this negative 0,549, we get minus 5,294. Okay, let's do this one here. Five 5,29 also. Right, so you need to show exactly what you see on the board. This is how you show working for your proof of the which is maximum and minimum. You will substitute the x value only, not both x and y, x value into the second derivative, and the answer that you get, you are interested whether the answer is a positive number or a negative number. Okay, so you do the substitution and you can say for this one here, therefore f prime of x is less than 0, that means it's negative. Okay, so you write down therefore this is less than 0, so minus 0,549 and 0,631 is a maximum. Right, so you write that down. If one is the maximum, obviously the other one cannot be maximum. The other one has to be a minimum. So therefore, 1,215 minus 2,113 is a minimum. A lot of writing to do, but nothing difficult, nothing that you cannot do. Okay, everything here you can work out easily, but you make sure you don't make any silly mistakes. This is 9 marks, easy 9 marks. Okay. Right, so the next question here in the November 2020 paper, draw. I didn't write down the whole question, I'm reading it out. Draw the graph of y is equal to x squared minus 4 and clearly indicate the enclosed area and the x-axis. Also show the representative strip you would use to calculate the area. So we should start getting familiar with your graphs now, because we're going to be using graphs a lot for applications of integration. This is N4, in N5, and then in N6. In N6, half of the exam is all about what we're doing now. It's about area, volume, and everything. So this is a parabola. When you see an equation, you must be able to determine in your mind what type of graph does this equation represent. Okay, so you know it's an x squared there, it's a parabola. So what do we need to find when we're sketching a parabola? It's x-intercepts, y-intercept, turning point. Certain graphs you can sketch it by inspection. Okay, but let me just do it the long way, so you can do it for any graph. So if I want to find the x-intercepts here, you let y equal to 0, so x squared minus 4 is equal to 0. So therefore x squared is equal to 4. So I need to find the square root of both sides. That means x is equal to 2 or x is equal to negative 2. Why? Because 2 squared is 4, negative 2 squared is also 4. There's two solutions here, you can see that. So then your y-intercepts, which you don't even have to work out, but you can see here, you let x equal to 0. So y is equal to 0 squared minus 4, which is minus 4. Okay. Turning point here. So for your turning points, find dy over dx, make it equal to 0 and solve for x, or minus b over 2a if you're using the not. When you're doing calculus now, it's easy to find dy over dx. Yeah? So dy over dx is equal to 2x. So then you make 2x equal to 0. You're clear with that? And then you solve for x. X is equal to 0 over 2, which is 0. Substitute the x value of the turning point into the original equation, and then you get -4. This all can be done very fast. Okay, so it's x-intercepts, y-intercept, turning point. Right, so you know your parabola. In this case, it's x squared, so the coefficient of x squared determines whether it's a graph that's going to be pointing up, which is a happy face, we call it, or down, which is a sad face. Now, what determines that is whether the coefficient is a positive number or a negative number. Right, that you know from school. This is a positive number. So therefore, it's going to be going this way, pointing up, happy face. Okay. So what are the x-intercepts here? 2 and -2. So let's go 1, 2, -1, -2. So this is -1, -2, -3, -4. We can draw this one. Yeah, it's not large values. You can use your ruler for this one. So there's your -2 here. -1, -2. This is 0. 1, 2. This is -1, -2, -3, -4. So all you do is sketch your parabola. There's it coming down there. So this is the graph. This is your 0, -4. That's 2. 0, -2, 0. Those are the x-intercepts, the y-intercept, turning point, everything on the graph. Now, the question stated the area bounded by the curve and the x-axis. So, can you identify this area? Enclosed, it must be a closed space formed between the x-axis and the graph. Okay, so if you look, let's start from this side here. There's the graph, there's the x-axis, but it's an open space here. Okay, even here too, from -2 to the left, it's an open space between the x-axis and the graph. We're always looking at the x-axis and the graph to find that enclosed area. So, as soon as you move from -2 to 2, there's the x-axis there, and here's the graph. So this is an enclosed area now. Okay, that is it. So this is what we're looking for. From there, there's the x-axis, and here is your graph. This is the enclosed area. Alright, so this is it. That is the area bounded by the curve and the x-axis. So what do? We need to draw that representative rectangle. Just one rectangle anywhere inside the area. You have a choice whether to use a vertical rectangle like this or a horizontal one. Okay, N5 you're going to be doing a lot of this here. Okay, and then you will see the many different ways we have to work out the area. Right, but now choose the easier option. For in this situation, I'm going to draw my rectangle like this here. So this is my rectangle. So here's my rectangle. Can you see that? Now, this rectangle can be drawn anywhere, starting from -2, ending at +2, anywhere inside here. But you need to make sure, if you're drawing a rectangle like this, make sure the top starts at the x-axis, the bottom must be touching the curve. Okay. Now, let's label our graph. We forgot to label the graph. Y is equal to x squared minus 4, and that is 1.2.1 for 3 marks. 1.2.2 is calculate the above area. Calculate the area. Right, so how do we calculate this area? So now, here is your rectangle. This rectangle has a breadth. The smaller side is the breadth, and the breadth here is, it's the difference between the two x values. Delta x means the difference between the two x values. Then the length is from top to bottom. This is the length. Okay, so the length is the difference between the y values. So what is the y value there? What is the y value there? Now, I need to go and check. So what is touching here now? And what is touching there? Okay. So that is the length of the rectangle. So let me explain to you what do I mean by the length. So let's say this is the xy axis, this is the y axis, and this is the x axis. Right, so let's say that's 0. Now, if I know that this is 3, okay, and this here is 10. So if I ask you, what is the length of this rectangle? Obviously, you're working it out in 1 second in your head. What is it? It's going to be 7. Because from here to there, you are moving 7 units up. In other words, all you do is 10 minus 3 is 7. So the length here is equal to 10 minus 3, which is 7 units. Okay, so if this was a 20 and this was 5, it's going to be 20 minus 5. Right, but the point I'm trying to make is that we are taking the y value at the top, subtract the y value at the bottom. Right, because we're talking about top and bottom. So what is the y value at this point here? What is the y value here? The y value, we have an x here, right? But we know on the y-axis, on the x-axis, y is equal to 0. And here, what's touching here is the graph y. You clear with that? Yeah, whatever it's all y, whatever y is at this point of here, we're not sure. Y is maybe, if it's minus 4, maybe y is minus 3 here. If I draw the rectangle here, maybe y is minus 1 here. But in general, it is a y value. So my length is going to be 0 top, just like how I'm going 10 minus 3, I'm going 0 minus y. Can you see that? Now, area. You're going to go delta A, area is equal to length times breadth. My length is minus y, and my breadth is delta x. Length times breadth. Okay, so total area. Once you write down total area, now you put in your integration sign. Delta x now becomes dx. We are integrating with respect to x. We need to know what is the lower limit, where it begins, the upper limit. There's this negative sign, can stay here, and there's my y. Okay, that is y. So now, what is the a and b? This is dx. That means we are integrating with respect to x. So therefore, we need to know what is the x value at where the area begins, the smallest x value. That is a, and the largest x value here is b, where it's, this is the beginning, this is the end. So there's the beginning, and there's the end. It doesn't go anymore. Yeah, can you see that? The beginning is minus 2, and the end is 2. So we're going to go minus 2 to 2. What is y? Y is the equation of the parabola, which is x squared minus 4. So we integrate, so that's going to be minus, integrate x squared, that will be, remember we are integrating here, so when you integrate k x to the power n, as long as n is not equal to negative 1, it's going to be k x to the power n plus 1 over n plus 1 plus c. So that's what we are doing, we are integrating them. So 2 plus 1 will be 3 over 3, integrate minus 4, which is minus 4x, substituting a positive 2, negative 2. Let's see what we get. So how do you do the substitution? You take positive 2, substitute into this answer here. So what am I doing now? I'm going to take 2, substitute into everything, and I'm going to write down. I'm just going to do it step by step here, not go to the final. So let me just type this out. So when I substitute 2, I get minus 16 over 3. Then when I substitute minus 2, I get 16 over 3. So minus 16 over 3 minus 16 over 3 is going to be minus 32 over 3. And now, this negative times that negative will give you a positive 32 over 3, which is 10. 10 times 3 is 30, remainder 2 over 3, 10 comma 667 units squared. And that is the area of this, the area bounded by the curve and the x-axis for the parabola.